Oh, there you are. I've been looking for you. Welcome to your first day at DeLorean. You're going to love it here. Now, here at DeLorean, we're revolutionizing the industry of time travel. With one push of a button on our app, you're going to be able to summon a driver in a DeLorean who'll come roaring around the corner. You jump in, and you get taken to whatever time period you want. Now, oh, by the way, I might mention to you, it's a little bit messy because we've got a lot of teams here, you know? So you might be a little surprised when you open the code base, but don't worry. It's totally normal for everyone to feel a little bit surprised when they first join. One thing you should also know is that we have several of these code bases. So when you implement a feature, you're going to have to check out this code base and that one and that one and that one. And not only that, we have some funny naming conventions around here. So when your product owner tells you about the FizzBang widget, don't forget it's actually called the foo bar doohickey, and which someone actually called the bar thingamabobber for some reason. Don't worry about it. It's just the way things are around here. And I know what you're thinking. You're thinking we need to really clean things up around here, which I'm sure, I promise you, we're going to get around to. But for the time being, I just really need you to be really heads down on our biggest, latest product development, puppy deliveries. And I guarantee you it's going to be a hit. Well, okay, it's time for stand-up, so I'll see you around. You'll get started with your team. Welcome to DeLorean. Hi, I'm Andrew, and I'm a software developer at Carbon 5. And like many of you, I've been a Rails developer for several years. And at Carbon 5, in prior jobs in the past, I've been a part of teams that worked on large code bases in Rails that have struggled to really scale as they've grown in size and complexity. Now, I've been thinking a lot about beautiful systems. What are things that make a system beautiful? We've talked a lot about beauty here at RailsConf. So beauty, as many of us Rubyists might think, comes from the language, in its syntax, in its form, in its expressiveness, whether we have nice DSLs that read like English. Or it could come from the tooling. It could come from developer ergonomics with beautiful error messages that are very helpful, or an amazing debugger. Or if you're in a different language, it could come from a great type system or a compiler. Some of us might consider beauty to come in the form of tests, whether our community encourages us to write great tests, whether there is the existence of a test suite that makes our code resistant to breaking changes. But what I want to propose to us today is that a system is beautiful when it's built to last, when it has longevity, and it stands the test of time with changing business and product requirements. These long-lasting systems are just large enough. They know their boundaries. They don't grow past them. They know what they're responsible for. They are highly cohesive and loosely coupled. And what that means is that they contain the necessary set of concepts within themselves, and these concepts are all close together. No need to reach outside to actually go fetch a concept somewhere else. And when I say they're loosely coupled, I mean that they minimize their dependencies on each other. And they have precise semantics that fully express their business domain. So when you jump into the code base, there's no confusion as to what it means, as to what business process it's representing or trying to implement. Now, some coworkers and I, for the past couple years or so, have been reading papers from computer scientists from the past. And we came across David Parnas's paper from 1972, in which he wrote on the criteria to be used in decomposing systems into modules. And he called this criteria information hiding. Here's what it said. He compared a software system. Its job was to process text, and it took in an input of words, and it basically did some processing on the text, and it shifted things and alphabetized things. And he compared two approaches in which he turned these systems into modules. So in the first step, he treated the program like a script. And he said step 1 goes into a module, step 2 goes into a module, step 3 goes into a module. And he says that that's probably the approach that most people would have taken with this program. But in the other approach, he divided it up by responsibilities. So he said, this module is responsible for line storage. This module is responsible for alphabetizing. This module is responsible for writing things out to the disk. And what might seem obvious to us 45 years later is that this is a good idea. And so what he concluded in the paper was that we divide up modules by difficult design decisions or design decisions which are likely to change. And by doing that, we insulate these modules from affecting the rest of the system when they change. So I wanted to bring this out and draw this out a little bit more because I thought this applied very well to software systems, meaning systems in our business. Where are the design decisions that are going to change in our company? Well, I want to put forth that this happens within the business groups that generate these changes. Here's an example. My team on marketing wants us to generate 5,000 promo codes. Now, on your team, finance wants you to implement a new audit log every time someone charges a credit card. And on your team, product wants you to implement food delivery. And then on my team, marketing says, oh, actually, we want 2,000 of those 5,000 codes invalidated. And then finance needs us to add yet another attribute to the log. And your product team wants you to now launch in a second market. And to me, that sounds like change divided up from the parts of the business that are driving them. So if we've ever worked in a nice greenfield Rails app, you know it feels really nice. So marketing asks us to do this, finance asks us to do that. You know, like it's easy to add features as it gets spread across the code. But as time wears on, we know it feels a little bit more like this. And then so the question now becomes, how do we get out of this large system that's doing too much stuff? Well, I heard about microservices, and I know that they're not easy. If there's anything that I've learned from attending any of these conferences, is that they come with an operational complexity that most people have failed to consider and realize only too late after stepping in. How much do we extract? Do I extract like one little feature? Do I extract an entire area of the code base? And where should I draw those boundaries? What if I extract something that's too specific? And then on the other hand, what if I extract something that's too generic? I once worked at a Rails company with a very large Rails monolith. And we realized as the engineering team, we needed to show something to our CTO about like where we wanted to take the architecture. Well, we had no idea. We didn't know if we needed, in the end, maybe like something on the order of 10 systems or 90 systems. I don't know. If only we had something to help us visualize what we need. Well, in 2003, author Eric Evans came out with a book called Domain-Driven Design. And in it are both a set of high-level strategic design activities and also very concrete software patterns. I must also warn you, there's a lot of enterprise speak in it, Java code or .NET code you'll find on the internet that will be very confusing, which certainly confused me when I first got my head into it. But my coworker told me at the time, you should really look into domain-driven design because I think it will help us. So today what we're going to do is we're going to pick an activity from domain-driven design called building a context map. And through the context map, we're going to learn some concepts from domain-driven design that will help us understand our systems. And then we're going to learn some refactoring patterns that we can then apply to incrementally organize our systems around the boundaries that we'll find out in our context map. So let's get started. Domain-driven design is very, very much focused on language. That's the first distinction that I usually tell people when they ask about the subject. And in the language, we have something called a ubiquitous language. And a ubiquitous language is not, it's not meant to be a global language for the entire company to use, but it's simply a shared set of terms and definitions that your team in your area of the business can agree on. And we typically use this language to drive the design of the system. So through the development of something called the glossary, we get people together in a room, and we simply get together and we write out the list of terms and definitions. This is it seems like a very straightforward exercise. So we simply come up with nouns and verbs that we use in our domain or within our team. So for example, over lunch, we might sit together and write on the whiteboard, okay, well, a driver is this thing. The driver owns the DeLorean, the driver drives around and provides driver services, the rider does this, and then your product owner might be like, wait, we call that a passenger. And you scribble out rider and you write, oh, actually, we're gonna say passenger. And then you might talk about events as verbs. So there might be an event in which we hail a driver, or there might be an event where we charge a credit card, so on and so forth. And the idea is that this list of terms and definitions is something that we codify either in a document or in the code so that we can all be in agreement about what words to use. And then we go on and we start renaming things in the code to follow the business domain. So, for example, we might have something in which we have a user requesting a trip. Now, there's two language things in here that we realized don't actually follow the business domain. So we go rename it. It's actually a passenger, and the passenger hails a driver. Now let's move on and let's go visualize our system. I'm gonna go generate an ERD diagram for us. And there are gems that do this for us, one of which is called Railroady, another one's called Rails ERD. And simply the goal right now is to get a lay of the land of the architecture of the system, using active record relationships to drive these relationships. So here's what something like that might look like. It's a little hard to read. It's very hard to read. Nobody will be able to read it. But don't worry, I've done the work for us. Most likely, if your company has a very large code base, this diagram is going to be gigantic. We once printed out ours at a prior company, and it was maybe like 6 feet long, printed out on roll paper. Most likely, it's going to be gigantic, and it may or may not actually be usable. If it's not usable, you may have to generate one by hand or something. So let's start by defining a few core concepts around domains. The domain of your business, the core domain, is the thing that makes the business do what it does uniquely to the business. So at DeLorean, our core domain is transportation. If you were Google, your core domain would be search. If you were Flickr, your core domain would be photo sharing. And then there are things known as supporting domains. Supporting domains are simply areas of the business that play supporting roles to make the core domain happen. So here at DeLorean, we have a team that's devoted to driver routing. And all they do is they come up with maps and fancy algorithms to route the driver to the right places. Or we have a domain for financial transactions in which we charge users credit cards or we pay their drivers. And then we have an optimization team that tracks business events and makes recommendations to the rest of the business on how to optimize certain business process. And then we have a customer support team, which manages user tickets and keeps people happy. So now what we're going to do is we're going to go discover these domains by using the diagram to help us think. So we're going to look for clusters on that diagram, and we might discover a few domains we haven't thought about. So you take a look here, and there may or may not be clusters that pop out at you. I'm going to do the work for us here. And I have come up with this, but as a team, you might come up together and make this a group exercise. Most likely, it will not be as clean as I've fakely made it out to be here. But for the sake of illustration, let's go with this. So now we've got a list of domains in our system, and we have a rough idea on what models belong in which domains. Now let's talk boundaries, because boundaries are an important concept that will help us divide up our systems. Now in our Rails app or in a Ruby app, we might have a boundary of a class. The class is the definition for a certain concept, but it's concrete in code, and it's meant to be a single boundary around one concept. A module could be a boundary across a collection of concepts, and it's simply a namespace for multiple classes to live in or something. Gems are another way to package up code that belongs together and ship it around. And then finally, things like Rails engines, Rails applications, external APIs could also be boundaries upon which other concepts are contained. So a bounded context is simply a software system. So when I put it out there and I say bounded context today, I will simply mean a running software system somewhere in production or could be a software system that could be run within your business. But since this is domain-driven design, there's a language component to it. So linguistically, it's actually a part of our domain in which concepts live and are bounded in their applicability. So what that means, you might think about it as a playground for concepts to live, but they're not allowed outside of that playground. And I'm going to spend a little bit of time explaining these a little bit more. The bounded context allows us to have precise language because it allows us to have terms that have conflicting, overloaded terms. It lets us separate them and give them their own playgrounds to run around in. Here's an example. We have a trip class, and to us, a trip is simply the thing that a passenger jumps into a car and they go for a ride. So that's a trip. There's a time and there's a cost on the trip. However, it's a little overloaded. In the financial transaction world, the concept of trip time is when the vehicle is moving. Folks in our finance department, they just made the decision that we're not going to charge the customer when the car is stopped. I don't know what that means when you're time traveling, but bear with me here. Trip time in the routing context is calculated when the passenger is in the car, no matter whether the car is moving or stopped. So you can see right here is that depending on what context you're in the business, whatever software system's using that, there's nuances in the behaviors for the same context. Or what about trip cost? How much money is the customer going to be charged? That's what cost means in finance. But when you go to the routing domain, trip cost is actually a completely different term. It's some made-up metric for trip efficiency, some sort of scalar metric. So those two concepts have similar names, but wildly different actual definitions. So what do we do? Well, if you're like me, what we might have done in the past is we might have simply just made it a little bit more specific, and then we would have just closed the box and walked away from it. And then what we've done here now is that engineers in the code will actually have to understand the nuances of these methods and understand that one is meant to be used in this context and one is meant to be used in that context. Just briefly here, we can fix this by introducing two bounded contexts. There could be a trip that belongs to the financial transaction bounded context and another one for the routing context. But we'll get into that a little bit later. So here's what we're going to do. We're going to go find the boundaries within our existing system using that diagram as a guide. So we'll also keep in mind that there are other systems in the landscape of our business. So things like other team services or other cloud providers. So over here, I've started out with our diagram. I'm going to pull out the ERD diagram from behind it just to make it more clear. And I'm going to draw a big circle around what I know to exist in our monolith. Here it is, the monorail app. And I thought a little bit more about it, and I realized that your team has the email service. And we actually use an AWS service called SNS to send push notifications to people's phones. We use Braintree to charge credit cards. And actually, in the process of drawing out these other systems, I actually realized there's some other domains that I haven't thought about yet. So I'm going to write them in. So customer notifications, another domain I haven't thought about. And there's some marketing, because marketing sends targeted emails to people. And then finally, I'm going to draw out dependencies between these bounded contexts. So I'm connecting these bounded contexts, and then I'm writing a U or a D. The U stands for upstream, the D stands for downstream. What that means is the upstream system is a system that is the source of truth for certain types of data. So the upstream system may provide the API. The upstream system may fire the message. Whereas if you're the downstream system, you are consuming or you are dependent on whatever the upstream service provides. And drawing out these directionality dependencies will actually help us understand the lay of the land, to understand the relationship our system has with other systems in the world of our business. You might notice a few things. A few things about the context map you might notice that one bounded context has multiple supporting domains. So this is very intuitive to many of us because we felt the pain of the monolith. That monolith did too much because it was trying to manage the code for all these different domains. Another thing we might notice is that there's multiple bounded contexts that have to support a single domain. So over here, we might notice that financial transactions and customer notifications both span several software systems. And that's just kind of a call out to us to make us realize that if we ever have to implement a feature in any of these domains, we're going to have to end up touching a few of these systems. And then in the end, there is an ideal or a suggested outcome that DDD suggests to us, that every domain is matched up with its own bounded context. So this might look something like this. This is certainly not a practical architecture for many of us, but if we took it to the extreme, every domain would have its own software system running behind it. You might also imagine this to be maybe the ideal microservice architecture. When I said that, I almost immediately want to take it back. But the idea is that everything is segregated to be highly cohesive within itself. Okay, now let's get to the actual code. So when we begin our first refactoring step, we only want to change a little bit of things at a time. So what I'm going to do now is I'm going to draw out one domain, and I'm going to make it a module. So let's say I'm going to implement a feature somewhere in ride sharing, and while I touch those features, I'm going to actually bring in some of those concepts into my ride sharing domain. So I'm going to start with the model and maybe its related classes, and I'm going to modulize it. I'm going to introduce a ride sharing module. And then I'm going to have to do the Railsy things to get the rest of the application understanding that this thing is now namespaced. Now I'm going to go move that code into a new folder. I've now made a second level folder called domains. And then within that, I'm going to start a new folder for every single module I've introduced. So over here, I've made a ride sharing domain. And I'm basically just dumping in all the code that I've collected for my models, my controllers, my views, or maybe even my services. And the idea is to move all that code that's related together into their own folders. This will temporarily make that ride sharing folder a little messy, but I want to put forth that it's okay in the interim. Now there's something also called aggregate routes. And the idea behind this is that an aggregate route helps us address the problem of God objects in active record. So we oftentimes have objects that know too much about the outside world, or the outside world knows too much about our object. So over here, we have an active record model that might be explicitly bound to other models in the ride-sharing domain. And this payment confirmation, as I've illustrated here, has a lot of relationships that may not be necessary. But however, the fact that they're all explicitly defined here makes it difficult to refactor, makes it hard to write tests, and it's just kind of awful to look at. Additionally, outside actors may actually know a lot about the internals of my domain. So I might have a payment flow that's a web UI that calls in and like it updates all these models, or I might have an external ETL process that runs nightly and picks and chooses what it wants out of my domain, or I might have a thing that pushes notifications to drivers and has to reach into my domain. And so the idea of an aggregate route is something that it's the idea that I'm going to expose only a single graph of objects to the outside world. So I'm going to simplify what I expose to the outside world so that the outside world has a reliable interface into my data models, and I protect my internal data models from being from change. So over here, I've decided, you know, my trip is going to be the route, and then the aggregate is going to be all these other models that flow out from the trip. And the idea here is that this trip now will expose everything else, but only through itself. And so anytime someone makes a direct method call to me, every time someone asks for the trip, I'm only going to expose that aggregate route through a JSON payload or through an API endpoint. You might have multiple aggregate routes per domain, which is okay. But just expose just enough to the outside world such that it makes sense. Now here's a quick thing that we can do. We can build a service object that will provide this aggregate route. So the idea is that I'm going to make a service object that will create a aggregate route that is basically a facade. So here's what I'm going to do. I'm going to introduce a thing called a fetch trip. And this fetch trip essentially is going to wrap a, over here I've written as an active record query that simply returns passengers and drivers on top of the trip. But alternatively, it could be a Ruby struct or something like that, just something to have data to pass back to the outside world. And now, callers in which used to be tied to my domain through active record relationships will now simply call the service object. And this service object will then return to them the related data models that they need. Finally, let's talk about event-driven architectures. In the past, we might have had to go somewhere else to do a side effect after we finish processing code in our domain. So over here, when a trip is being created, this code then reaches out and does something in an unrelated domain, which ends up coupling the two domains. So over here, you can see that a ride-sharing concern then has to perform something in the analytics domain as well. What if we flipped the data dependencies? So instead, what we're going to do is we're going to go publish an event, and then we're going to go have the other domains subscribe to that event. And so therefore, we lower the coupling between our domains. I will now introduce a thing. So I'm essentially introducing a message bus. And within this message bus, I'm going to introduce a publisher, and we're going to have subscribers or handlers to handle these events. And I'm doing this through a gem called Whisper. Whisper provides publish, subscribe semantics for Ruby applications. And so, so here the domain event publisher simply passes through an event and then calls through Whisper to publish the event. And on the other side, or sorry, here in the original code, instead of reaching into the other domain, I'm just going to fire the event. And now, on the other side, every bounded context is now going to handle or respond to this event depending on whether it needs it or not. These handlers will also use things called command objects to basically perform their side effect. So over here, I've made a domain event handler. This domain event handler will listen to the trip created event through the definition of a class method called trip created. And so therefore, every time an external publisher publishes trip created, this domain event handler turns around and fires the log trip created command. Here's the glue code in which Whisper is set up to subscribe to events. So the event handler is subscribing to events from the publisher. And this is a illustration of what the command object looks like. The command object is a simple, lightweight service wrapper around a specific side effect that has to happen. We might also see that other domains need to also respond to these events. And so over here, we are introducing some extra behavior that is now decoupled from that controller. And so in the financial transaction world, we would also do things like creating audit logs, or we deduct gift card amounts, et cetera, et cetera. So this is kind of the end result of our new architecture, where we introduce a message bus. It should also be noted that this is technically not a message bus in the asynchronous manner yet. Whisper actually just has some nice wrappers that allow you to make it look like it's async, but it's actually still synchronous in the web request. Until you introduce the active job wrapper, and now your handlers will now be queued up as active jobs. And so this allows you to actually make your side effects asynchronous with your worker queue framework of choice, like Sidekick or Rescue. And then here's the glue code to make that happen with active job. Finally, you can also introduce a real message queue. So if you actually want to decouple your systems to other external systems, you might introduce a thing like RabbitMQ. And there's a few nice gems that let you do that. Stitch Fix has a nice one called Puka. There's also a gem called Sneakers. Let's talk about a couple of more advanced topics. The first one of which is what happens when we want to share models between domains? Let's say I have a system that's off here and I have a system here, but they actually still need to access the same data. Well, there's a concept called a shared kernel in which we simply we make it okay to ship around a certain shared package. And so what I suggest in that case is we simply namespace our models under that shared namespace. And this could actually become a gem if you have to ship it to external libraries or not. But I would also say that if you find yourself sharing a lot, you're maybe not thinking about your domain clearly enough. Because there might be an actual thing that you want to do, which I'm going to talk about next, is when you have one model that actually needs to belong in two domains. Sometimes you have a concept that just has to be broken up. And how can you get these concepts codified within their respective domains? Now, there's something called an anti-corruption layer, which I'm going to introduce, which is simply an adapter that maps a concept from the outside world into a concept that we can use within our domain. So here's an example. So remember that trip that I introduced earlier on? Well, we know that it actually has the semantics for two domains. So what if I introduced a nice, very expressive domain model for the routing context here? So over here, that's a really beautiful domain model that has language that really reads and flows nicely and matches the business domain. And what I'm going to do is I'm going to make an adapter that simply maps us from that legacy data model into our internal data model. So there's simply a mapping function that just maps things together, and then it converts and instantiates our pure domain model internally. And then we're going to add a repository in which we simply grab the thing from the outside, and then we instantiate an adapter which converts us to the internal model. And now internal domain code is going to call the repository instead of directly reaching for the outside world. Let's talk about what happens next. So one would imagine that you can apply this incrementally. So the beauty of this is that you can apply one or a few or maybe all of the refactoring patterns, and you might move things first into incremental domain-oriented folders. So you might simply pick and choose, move things, and drop them into folders. Next, what you could do is you could turn those folders into Rails engines, so they're actually self-contained applications. And then next, you can move these actually into their own Rails services. And then finally, you can move them to whatever language or whatever you want to use of your choice. And the idea here is that actually, as you continue decoupling these things, you allow your systems and your teams to scale because they're going to actually be able to run in isolation from each other slowly but surely. Okay, I want to throw up a few caveats because this happens to be very true. DDD will work very well for you if, one, you have a complex domain. You need the linguistic precision. You find yourself really caught up or tripping up over words or names or meanings. Or maybe your business is just very complicated. You have a lot of regulation in your domain or something. There's just a lot of nuances to your domain. Second of all, you might work in a very large team. You just might have a massive team working on a massive code base. So this might actually help you isolate your systems well. Third, you're open to experimentation. You have buy-in from your product owner. And fourth, your whole team is willing to try it out, including other teams. So if you're the lone wolf that wants to kind of slide this under the door, this is not going to work. You need to have buy-in. You need to have agreement that, hey, we're going to try out this new architecture, and we're going to try out a few of these refactoring steps. How does it feel? If it doesn't feel good, maybe you need to have second thoughts. Or if somebody's really against it, this may not work. This is in response to a presentation I gave earlier. There was a conversation on Twitter, and somebody said, hey, you're just doing Java. And then I had this thought like, oh my God, like, are we becoming the thing we hate? Just kidding. I actually have a lot of love for Java. But I would say that in Ruby and Rails, we oftentimes have this search we're on this quest for simplicity. But that may not necessarily be the best thing in every case. Because in domains where there's some necessary and essential complexity, maybe what we need to be searching for is clarity. So with that in mind, I want to share with you some things to be on the watch for if it doesn't feel right. When do you stop? So hopefully you've been applying these incremental refactorings. But at a certain point, you might feel like, wait, I feel like I'm over-designing. I feel like there's a little too much going on here. Or it feels like it's kind of silly just to make this thing do that thing and then plug this thing into here. Second of all, you might feel like maintaining these abstractions is kind of a burden. You're just like doing things just for the sake of following the patterns or the book. It actually might be okay to simplify things. Instead of creating a pure domain, instead of creating a service that does this to an adapter that does this to this other repository, you might be able to get away by smashing those three things together into one object and then calling it a day. It's okay. And then finally, if other teams are silently grumbling, or they're very obviously grumbling about it, then maybe it's time to stop and have a conversation. It's okay. You don't have to follow this by the book once again. The beauty of this, once again, is that we incrementally refactor, we incrementally apply things. So in summary, we discovered the domains in our business, and we developed a shared language with our business. We built a context map, and so we saw some strategic insights, and we saw the lay of the land. And then finally, we found some refactoring patterns and some organization strategies to help us organize our code bases to hopefully get us to that next step so we can build out systems that will really scale. And with that, I want to thank RailsConf for inviting me here. Here's all my contact information. If you'd like to talk, I'd love to talk with you afterwards down here. Thank you very much.